Hey everybody, so we're back working on tests and confidence intervals for paired versus independent data. Today we're going to do problem 11.8. I will probably do 11.9 and 11.10 in separate videos just for size purposes of the video. Okay, the Gun Show Protein Shake Company claims that their protein shake helps build bicep circumference by up to 10% in just 6 months. Sign me up. When asked to provide evidence for the claim, they provide documentation of a study performed on 8 randomly chosen mid-tier bodybuilders. In the study, the 8 bodybuilders had their biceps measured to the nearest half centimeter, then were asked to drink Gun Show daily before their normal workout routine for 6 months. At the end of that period, their biceps were measured again. I really want to try this. The study resulted in the data below. Okay. I feel like that is going to be important for us to write down, so I'm going to put circ, which is circumference before in centimeters, and circumference after in centimeters. Okay. Really want to go measure my bicep now. It's like 12 centimeters. I'm kidding. Okay. Add a new row to the dataset called change. These values should be positive if the biceps increased in size. Okay. Alright. Okay. So this first person, their bicep went down a centimeter. This person's went up 4. This person's went up 2. This person's went down 2. Up 3. Up 1. No change. And down 1. Okay. B. Sketch dot plots or histograms with a bin width of 1 for each of the 3 rows, before, after, and difference. Which ones appear to have outliers? Okay, well, I'm going to choose the dot plot if at all possible. It looks like I need to go from 39 to 50. Okay, so here's the before. Okay, so 45, 39.5, 42, 46, 41.5, 40, 42, 49.5. Okay, so now I'm doing the after, so 44, 43.5, 44, 44, 44.5, 41, 42, 48.5. Okay. Change is obviously going to have a different scale. -1, 4, 2, -2, 3, 1, 0, -1. Okay, great. C. Looking at the data, where does it seem the company got their up to 10% claim? Okay, so that is this guy right here, because he gained, right here, he gained about 4 centimeters, and he had about a 40 centimeter circumference. So from bodybuilder to who had a 4 centimeter growth. Okay. D. The gun show company would like to be able to claim that the gun show increases bicep diameter within 6 months on average for their mid-tier bodybuilding customers. Explain why their study as designed could never truly allow them to draw that conclusion. Okay. So this is something important and something kind of new-ish. It's kind of old and kind of new. What you'll notice in some of these tests and confidence intervals is there's going to be experiments and observational studies. Observational studies are surveys where people are randomly selected to do something. And experiments, as we've talked about before, you can't randomly select someone for an experiment. That's unethical. So the randomness comes in choosing which one will do the treatment and which one won't. In this particular case, you have an experiment. So first, let's say this is an experiment. And there's a problem. So first of all, with experiments, they establish cause and effect. From random assignment. One of the problems with this, there's two problems. First, you won't be able to generalize this to the population. It's just cause and effect only for your people. But there's also another problem here where the experiment itself is poorly designed because there's no control group. So there are two reasons why they can't claim that this will increase the biceps of every mid-tier bodybuilder. First of all, because it's an experiment. Experiments help you determine cause and effect, but cause and effect only for the people that you had do the experiment. And then also, this particular experiment is poorly designed because there's no control group. So you have no idea if it was the gun show drink or whatever, or if it was just that these people worked out, or all other kind of variables in there that could change your results. Okay, E. The gun show company could theoretically make the claim gun show is associated with a statistically significant average increase in bicep circumference. Okay, based on this study, if an appropriate hypothesis test on the differences confirms their statement, check the differences satisfy the conditions for inference using a t-test. Note that it does not matter if the original rows satisfy the conditions, only the difference row. Okay, so if you're wondering why we made those dot plots a few minutes ago, here is why. Okay, so we have random, independent, and large counts. And for randomness, they did say they had 8 randomly chosen mid-tier bodybuilders. So randomly chosen. Okay, there were 8 chosen, so 8 times 10 equals 80. Is this less than or equal to all mid-tier bodybuilders? I'm sure there's more than 80, so that's okay. Okay, and here's where the large counts condition comes in. So, and the whole reason we did this. What you do, so first of all, 8 is less than 30. Okay, so I'm just going to put my straight line emoji face. And what you want to do is look at the change graph. So large counts. You want to look at the change graph and see if there's any extreme skew or outliers. In this case, it's almost uniform. So dot plot of change shows no extreme skew or outliers. Okay, so if you were wondering why the heck we were making those, it's because I wanted to show you first that just because these two have super high outliers doesn't mean that there's going to be an issue with your change dot plot. These graphs have high outliers, but because you're working with the differences, you have almost a uniform distribution there, which is great. Okay. F. Perform a complete t-test on the difference data to see if the company has sufficient evidence for their claim in Part E. You do not need to check the conditions again. Hint, if their claim is incorrect, what will the average difference be? Okay. Alright, so we're going to do our first paired data t-test. And we're starting with the identify section. So this is how this goes. Identify. And because it's a test, you need the null hypothesis, the alternative hypothesis. You need to know what alpha is. And then you need to have some kind of statement of context. Because it's paired data, you use mu d for mean difference. And so we will talk about that in a second. Okay, so, and notice we have our differences calculated here already. Alright, so what we want to do is see if there was any change whatsoever. So mu d equals 0. And then the claim is that the biceps got bigger, so mu d is greater than 0. And alpha is 0.05. And true mean difference in bicep size. Okay, so what's different between this and the t-test from chapter 10? You have little d's here and here, and here. You have the word difference here, but that's it. What you do is you treat this as one sample and then follow exactly the same process as a one sample t-test. Okay, so for the conditions, we're just going to see part E that we already did. Calculate. Okay, let's talk about whether or not this is T or Z for a second. And interestingly enough, you don't have the sample mean or the sample standard deviation in this case, but you do have a list of the actual, notice I said list, of the actual changes. So what I have done, and hopefully some of you saw this, I have gone to stat, and I'm just checking to make sure that you guys can see this. Come on, camera, focus. There we go. Okay. Stat, edit, okay, and then I have typed the list of changes into L1. So I did, just up here, I did -1, 4, -1, 4, 2, -2, 3, 1, 0, -1. I put those in L1. Stat, calc, one variable stats. Okay, and what I want to make sure is that you guys don't have anything in your frequency list, because that would have something in L2 and we don't have anything in L2. We don't have frequencies to worry about here. So I have L1 in my list, enter, enter, enter. Okay, and what do I need from this? I need the mean, the sample mean, and I need the sample standard deviation. So x bar and s of x, I'm going to write that down. X bar equals 0.75 and s of x equals 2.12.1213. Okay. Notice I could estimate the population standard deviation here, but I don't really have it. All I have is sample information. So I'm going to do a t-test. T equals, okay, statistic minus parameter. So my statistic is x bar, and parameter is whatever I have plugged in the null hypothesis, so that's 0, and over standard error of the statistic, so that's standard deviation over the square root of n. Okay, and this actually comes out to be 1.00. Degrees of freedom in this problem is 7, because you have 8 bodybuilders minus 1 is 7. Okay, and then p-value, TCDF, my low is 1, my high is infinity, my degrees of freedom is 7, and that gives me about 0.175. Conclude, since our p-value of 0.175 is greater than 0.05, we fail to reject the null hypothesis. Okay, so I've failed to reject it. There is no difference in the bicep size. Okay. Great, that problem is done, and I will see you guys in a moment for number 9.